Now we come to mixed combination of cells. Now by the term combination of cells, we mean either they can be in series and parallel separately. And now by mixed, we mean to say that they are in series first and then in parallel. So we have an arrangement something like this. We have a number of cells in each row and there are very many rows here. So like that it goes on. There can be many rows like this. And then this whole arrangement is connected to an external resistance which have a value of capital R. Now this is what we have for the circuit. Now each of these individual cells are similar in type and each of them have an internal resistance of small r and an EMF of small e. And say there are n number of cells in each row and the number of rows is m. So let's recapitulate here what we are having total. We have a number of cells in each row. There are m number of rows and in each row we have n number of cells where each cell is similar and having a potential drop or EMF of E and an internal resistance of small r. And here is an external resistance capital R across which the mean current, that is the current coming from this combination of cells, is flowing through. Now we are going to get the value of the current. Now before getting on to the current, let us find out the value of the resistance of this combination here. Now you see in this chain, all the resistances are in series. So for each chain, we have an internal resistance of R into N. I hope it is clear to you all that for each chain, we have a resistance of R into N. And then how many rows are there? M. Say for example, we have two resistances small r and they are connected in parallel. Then we know that the equivalent resistance is R by 2. When there are three resistances and they are in parallel, we know that the value is R by 3. So when there are Rn resistances and m number of rows, then we have the equivalent resistance as Rn by m. So that is what is the equivalent resistance here stands for, which is Rn by m. So now we have a situation where we have the total internal resistance of the cell as Nr by m. Now as you can see from the figure that here was the cell and this was the external resistance connected here. So the same current is flowing through the external resistance. So the total equivalent resistance now happens to Nr by M plus capital R. Why? Because these two resistances are in series. Here the resistance was Nr by M where the cells were combined. Now for the current, as we all know, is EMF by circuit resistance. So I hope it is clear to you all that if all the cells are having same EMF, then for each chain the EMF is NE. And as we have just discussed previously that if there are similar cells connected in parallel, then no matter the number, the equivalent EMF is NE. So the current here happens to be NE divided Nr by M plus capital R, which comes to MNE. Then here it is NR plus M capital R. Now what's next? Well, we have a value of this MNE and then it is NR plus MR. Now this M into N is what we call the total number of cells. So mind you dear students, the total number of cells is M into N and that is equal to capital N, which is the total number of cells. So the total number of cells will be given to you and in that case you have to calculate the total number of cells as capital N. Now comes the next part of the whole thing. This current, or rather I will put it in some different way, that what was the objective of making this kind of a combination? The objective, you know, to maximize the current. Now in order to maximize a current in a circuit, what we require to do is the value of the external resistance should be equal to the equivalent internal resistance of the circuit. So the net resistance of the external circuit should be equal to the equivalent resistance of the internal circuit. So the internal resistance equivalent and the external resistance equivalent should be same. Now to put it simple, what we know from this particular circuit is the external resistance is R. And what about the internal resistance? Well, it is Nr by M. So we have a condition here that Nr should be equal to Mr for the maximum current. So this is the condition what we have for cells, that NR equal to MR, which is the condition for maximum current, or in other way it is nothing but the fact that the internal resistance should be equal to the external resistance, and then we can know the exact value of current which flows through the circuit, and the current that flows through the circuit in that case is INE NR plus MR. Now as we know that this is equal to this, so we can write it either as 2NR or as 2MR, and in that case the current will be maximum. So this is our actually objective, that to make the current maximum, what we are doing is NR by M is equal to capital R. So this is what we have for a mixed combination of cells, where we have to remember that the cells have to be similar and they have to be conjugate, and the objective of doing the whole thing is deriving a maximum current, for we have this condition to be applied. Thank you, dear students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.